Hello students and welcome to our today's class. Today I want us to focus on the perpendicular lines. So in this particular class, our focus will be on how we determine the equation of a line which is actually perpendicular to another line, having been given uh, some coordinates or equation of the other line. So therefore, our focus will be what is the characteristic of the lines that we normally refer as perpendicular. So you will come to understand that a very key characteristic about the perpendicular lines is that, let me write the subheading, the perpendicular lines. Perpendicular lines, they have got a very crucial characteristic which we normally use in manipulating them or solving any equation that is touching on them. And this characteristic is that the product of gradient or gradients of perpendicular lines is -1. The product of gradient of perpendicular lines is -1. So first of all, you need to understand the perpendicular lines. Perpendicular lines are those lines that meet each other at an angle of 90 degrees. So if we have a line like this and the other one like this, and they meet each other making an angle of 90 degrees at the point of intersection, then this line, maybe this is L1, this is line 2, these two lines are said to be perpendicular. So perpendicular lines are those lines that meet each other at an angle of 90 degrees. If that is the case, then we normally refer to them as perpendicular lines. And as I've said here, the product of the gradient of the perpendicular lines is -1. So if, for example, we have the gradient of this line, which we can refer as m1, because we know the equation of a line is given by y is equals to mx plus c, where m is the gradient. Therefore, if we have the gradient for this line as m1 and we have the gradient for line L2, which is now given as m2, if we multiply the two gradients, m1 times m2, this product must give you -1. That is what we mean here. The product of the gradients of perpendicular lines is -1. You multiply the gradient of this line times the gradient of this line, then they should give you -1 if, after all, those lines are perpendicular. We can have this other example whereby you are told that two lines have got the following equation: y is equals to 1 over 3x plus 1, and the other one is y is equals to -3x minus 2. Then you are told, without drawing, determine whether these two lines are perpendicular. Without drawing, you determine whether these two lines are perpendicular. What you need to do is to note the gradient of these two lines and then multiply them to confirm whether it is giving us -1 or not. So in this case, our gradient, which we can refer as m1, is 1 over 3. The gradient of the other line, m2, is -3. This is a third and this is a -3. Therefore, a third times -3, we will need to confirm whether it is giving us -1. And you find that actually it is giving us -1. Therefore, these two lines whose equations are given here, the lines are perpendicular to one another. You can be given another example, and the example is like this. You are given right now, or equation 1, which is y is equals to 2x plus 7, and the other one is y is equals to -2x plus 5. Then you are asked, without drawing, determine whether these two lines whose equations are given, they are actually perpendicular or not. What you need to do is the same. You do 2 times -2. This is m1 times m2. always the number that is next to x is the gradient. So the gradient for this line is 2, the gradient for this other line is -2. You multiply them and confirm whether it is giving us a -1. You find this one is giving us -4. Therefore, these two lines are not perpendicular. That is actually the testing point. This is actually the testing point, whether the gradients are actually giving us a product of -1 or not. If the product is -1, then the lines are perpendicular. If they are not, then they will not give us -1 as the product of their gradient. You can also be tested this way, where you are told this, that determine the equation of the lines perpendicular to the lines. You are told this. Determine the equations of the lines perpendicular to the line, to the lines whose equations are given, and given that they pass through the points given. So you are told to determine the equations of the line perpendicular to the lines whose equation is given, and those two, and the points, or the line that you are looking, its gradient passes through a given point that you are also given. Like number 1a here, you are told you determine the equation of the line that is perpendicular to y minus 5x plus 3 is equals to 0, and that other line passes through 0.32. So what you need to do here, remember you have been given this equation in this form. What you need to do, you need to express this equation in form of y is equals to mx plus c. You change it from this form to y is equals to mx plus c, whereby only y will remain on this side and the others to go to the other side. So here you will find that this equation will be equal to y is equals to -5x will go to the other side to be positive 5x, positive 3 will go to the other side to -3. So in this case, the gradient, our m1, the gradient is actually equal to 5, because that is the point or the number that is next to x. Having noted that, then you can be able to know the gradient of the other line. If these 2 points or these 2 lines are perpendicular, then the gradient of this line and the gradient of this other line that passes through this point, the product should give us -1. So we can say here 5, which is the gradient here, times m2, the gradient of this one, which we don't know, they need us to give us -1 if they are perpendicular. So we are actually looking for the gradient of this line such that that gradient times the gradient of this gives us -1. So you will find that m2 will be equal to -1 over 5. I've just divided everywhere by 5 by 5. So m2 is this gradient here. After determining that, the gradient of the other line, that is m2 is equals to -1/5, and we know it passes through the point 3, 2, then you can be able to determine the equation. From what we know, equation of a line can only be obtained if we have one point and the gradient. In this case, we have got those factors. So we assume another point here, xy. This other line also passes through xy. So if we do change in y over change in x, then they should give us this -1 over 5. So y minus 2 over x minus 3, they need us to give -1 over 5. If you cross multiply 5 to multiply here, -1 to multiply here, you'll find that 5 into y minus 2 is equals to -1 into x minus 3. what will follow? Then it will be like this. 5 times y is actually 5y minus 10 is equals to negative 1 times x is actually negative x. Negative 1 times negative 3 is actually positive 3. Therefore, 5y, I'm just taking 10 to the other side, is equals to negative x plus 3. Negative 10 will come to this side to be plus 10. Therefore, 5y will be equal to negative x plus 13. So y, we divide everywhere by 5, by 5, by 5. So y will be equal to negative x over 5 plus 13 over 5. And actually, this is now the equation that we were looking for. I want you to note the procedure keenly. You are given this equation, but this equation was not expressed in form of y is equals to mx plus c. First of all, we needed to express it like that so that now we can have our gradient, which is represented by m here. Once you have that gradient, then because we have been told the two lines are perpendicular, then we need to get the gradient of this other line such that when we multiply the two gradients, they give us negative 1. And if we do so, then you will find that m2 is going to be 1 over 5, which is the gradient of the other line perpendicular to this. Now that we know the gradient and we have been given one point where that line passes, then we can come here and assume the other point to be xy. As we did anytime we are looking for the equation, we must assume a point xy, and then we do change in y over change in x. This should give us this. Through cross multiplication and working out on the equation that will come out, we shall find that this is actually going to be the equation of that particular perpendicular line, which is actually straight. I want you to try this on your own. The question remains the same. The statement remains the same. Determine the equation of the lines perpendicular to the lines whose equations are given, and given that they pass, this is supposed to be they pass through the points given. So I want you to come here and you try this, whereby you are given the equation is y is equals to 8 minus 7x, and then the other line passes through negative 3, negative 4. You determine the equation of this line that is perpendicular to this, and you can go ahead. Remember this one, just but accrue, you need to reorganize it to be in form of y is equals to mx plus c, so that is negative x plus 8. Now from there, you can proceed. Thank you very much and have lovely moments. Let us meet for our next class next week.